All right, virtual learners, in this video I am going to show you how to make 10, which is a super powerful addition strategy, one of my favorites and the one of them that I focus on the most when I'm teaching addition strategies. This aligns to Virginia's first and second grade standards. Here's the specific standards. For first grade, the student will create and solve single-step story and picture problems using addition and subtraction facts to 20. That's the VBO right next to it. And then in second grade, students will demonstrate fluency with addition and subtraction within 20. I forgot to write the VBO for that one. But the big thing to understand is that as soon as kids run out of fingers, because we only have 10 fingers, we cannot rely on our fingers to count anymore. We need to develop more efficient strategies for addition and subtraction. One of the most efficient strategies for addition is to make 10. Now there are some prerequisite skills to this, and one of the prerequisite skills would be that you want your student, your child, to understand the partners of 10, all those two atoms that would make 10, 1 and 9, 2 and 8, 7 and 3. There's another video on my channel for that if your student is not there yet. The other prerequisite strategy that they need to be able to understand making 10 is they need to have a good understanding of teen numbers, meaning that they understand that 13 is 10 and 3 more, or that 10 and 4 makes 14 without having to count. Okay, so those are prerequisite skills for this. Once they understand those partners of 10 and once they understand teen numbers as 10 and some more, then they're ready to make 10. All right, so I usually use two-sided counters with this at school, but I know that all parents don't have two-sided counters at home. So I just pulled some stuff out of my pantry that you could use as manipulatives at home. I got some M&Ms, I got some goldfish, I got some dry pasta, and we're going to work on making 10 here today. Okay, these little grids on my whiteboard right now, they're called 10 frames, or if you have two of them together, sometimes they're called a 20 frame. And the reason why they're called 10 frames is because they can hold 10. Students start practicing with 10 frames in kindergarten, and we can use them all the way up as we explore numbers since our number system is base 10. So let's think about a problem, an addition problem that I would not have enough fingers for. Let's think about a problem like 9 plus 5. I'm going to set up my 10 frames to show 9 plus 5, okay? And my first 10 frame. Now, parents, you can Google 10 frames. They have free 10 frames out there if you wanted to print some. I just drew some because I wanted to make sure that I'm showing how you can work on math. As long as you have a writing utensil and something to write with, you can teach math. So on my first 10 frame, I'm setting up 9 fish. This is a good chance to talk about what do you notice about 9. You want to notice that it's just one more, and I would have 10. Some students might also notice that it's 5 and 4. 5 and 4 is a way to make 9. Some students might even say, I see 4 and 4, and I know that's 8, and one more is 9. And those discussions are super powerful to have because anytime that you're talking about numbers and number relationships, you're building number sense. So I have 9 in my first frame. I'm going to use 5 of something different in my second frame so that I can see the 9 and the 5. If you have two-sided counters, then those are counters that have one color on one side and one color on the other. Then you can use the same counters and just flip them to the appropriate side. But I know not everyone has two-sided counters at home. All right, so again, say you have 5 here. It's okay if you set up 5 like I did. So a student might see this as 4 and 1 more. It's also okay if you had it set up like this, which is half of 10 is 5. There's no right way to set up a 10 frame, so please don't tell your students they have to set up their numbers a certain way. In fact, it's really powerful to have them experience and practice setting it up in different ways. Even if I wanted to, I could do, let's see. This helps me understand 5 as 2 and 3 more, okay? All right, so now that I'm trying to do 9 plus 5, less efficient strategy, but still more efficient than counting all would be counting on. So if you're starting Make 10, probably a strategy that you might expect students to use off the bat would be counting on, where they say, I already know I have 9 and I'm going to count on 9, 10, 11, 12, 13, 14, but I don't want you to have to count at all. I want you to be fluent with these facts to 20 without having to count. So let's think about how I can move these counters around to make an easier but equivalent problem. If I just took one of these M&Ms and brought it over here, I don't have less M&Ms, I don't have more M&Ms. All that I did was shift one over to make 10. You see how I did that? Or I can think I'm going to break up my 5 into a 4 and a 1. That way I can shift this over to make 10. So now I can see that 9 plus 5 is really the same as 10, and then there will be 4 left, plus 4. And if I know my teen facts like 10 and 4, I know easily without counting that that is 14. This is how you can show this same strategy abstractly without all the manipulatives. So you can say, okay, well, I'm going to break up my 5, use a number bond, think of it as 1 and 4, because then I know 9 and 1 more makes 10, and then 10 and 4 more makes 14, so that I know 9 plus 5 is 14. Okay, let's try another one with a different number. You can do make 10 with any addition fact that would have a sum over 10. So you could do a 7 plus 4. You could use do a 6 plus 7. I usually start with 8s and 9s for make 10, just because 8 and 9 are close to 10. And then that way they know how they can make 10 that way. There's other strategies out there too. I'll probably do some more videos like doubles or whatnot. I'm going to leave that one there. Let's try 8 plus, you know what, I'm going to make my 8 on the other side this time, because we want to make sure that we present it both ways so that they can use that commutative property. I can make 10 on either side, right? Go back there, M&M. All right, and I'll do 8 plus 6. Well, this one will really be 6 plus 8. All right, so let's take a look at a problem like 6 plus 8, and let's see if we can make 10. So the first thing I would ask students to look at is say, look at your 10 frames. What numbers do you see? Well, I see 6 and I see 8, and we can have that conversation about how do you see it. That's fine. Okay, so then if I wanted to make 10 so that I wouldn't have to count, even if we're counting on, I'm starting at 8, 9, 10, 11, 12, 13, 14, that's still having to count. I don't want to count. How can I make 10? Which of these numbers, 6 or 8, is closer to 10? Well, 8 is closer to 10. How much more would I need to make it 10? Well, I see 2 spaces here, so I would need 2 more. So if I shift 2 of my fishies over here to make 10, I don't have more fish or less fish. I still have the same number of manipulatives on my board, but I've changed it into an easier equivalent problem, because now I'm not seeing 6 and 8. Now I'm seeing 4 and 10. And if I know 4 and 10, that's the same as 10 and 4. Well, 10 and 4 is 14. Look how easy that was. I didn't even have to count. So that, my loves, is make 10. Make 10 is a super powerful strategy. I usually teach that as one of my first strategies for addition. Once I'm getting sums over 10, then I focus on doubles and near doubles. And then you will notice, and I also make sure students do have counting on, because counting on is a big one too, especially when you only have a few numbers like 6 plus 2, 6, 7, 8. But then once I make sure that they understand some good strategies, you'll notice students will become flexible with the strategies, and they will use the strategies that best fit the problem that is in front of them. And that's what we want them to do. All right, well, thank you so much for tuning in, learning how to make 10. Happy practicing.